Okay, we're broadcasting. Hi everyone, and welcome to our final project presentation. For our topic, we chose to calculate statistics on donations to US election campaigns. My name is Mita Kude, and I am joined by my two partners.
Hi, I'm Xiaolong.
First, Xiaolong will give us a little background on this topic.
Okay, first I want to talk a little about what this project is about and why it's important. Campaign donations have come under increasing scrutiny over the past few years because of the abuses to the system that have come to light recently. For example, tech money, which we have begun hearing more about. Tech money is money donated to election campaigns that doesn't need or get to be reported in the candidate's FEC filings. One way to do this is the case of non-profit corporations who are able to legally make issue advertisements endorsing or rejecting a candidate by name as long as they do not tell their viewers to vote one way or another. In the 2008 presidential election, non-disclosed spending hit a record about $78.8 million. In some cases, even with that money that gets disclosed, there are still hidden intentions behind it, such as in the case of Super PAC. It's possible for candidates to make donations to Super PAC supporting themselves through corporations that they own. Corporations are even able to donate to candidates with the intention of getting legislation that benefits themselves. It's important for citizens to know who their candidates get money from in order to know where they are interested in. All of this information is public record on fec.government. You can search whichever queries you want, and maybe even find out where your district's congressperson gets campaign funding from. For this project, we decided to focus on three queries specifically. First, what are the sources of candidates' maximal campaign donations? Second, how much does each state contribute in total to their candidates' campaigns? The last one, how much money do candidates report as contributing to their own campaign? Now we collect candidate information for different campaign years in different fields. Every line of database dataset is formatted at value 1, 2, and 3. We use string.split to divide each line into an array of strings for ease of finding specific data values. And we choose MapReduce. Why we choose this? Because of its increased testability over pig and hive, as well as the amount of control it allows in processing large unstructured data systems. We also use 3-node Hadoop cluster of AWS Media Instance, where the node also functions as a data node in other nodes with processing power. Now, let my groupmate Mita tell us how this application implements.
Thanks, Xiaolong. So before we begin talking about application design, I just want to quickly go into how MapReduce applications work. So first, the input data is split by file. Then each file enters the extended map class, where it is processed, shuffled, and sorted. The map method gets run concurrently on multiple files to speed up execution, so it must be thread safe to avoid updating the wrong variable. Once you have completed processing the data in the map method, you write a key value pair to the context to be reduced by the extended reduce class. The reduce method within the reduce class organizes and collects the data from the map method, and the result is your output. Now we can talk about how I designed the programs. The first class determines how much each candidate spent on their own campaign. we extended the mapper and the reducer class. The map method within the mapper class calculates percentage of each campaign that was funded by the candidate themselves. It then writes a key value pair containing a range of percentages and a counter to the context in text in writable form. After that, the reducer class sums the key value pairs from the mapper class to find out how many candidates funded their own campaign at each contribution level. Our second class determines what kind of donation constituted the maximum for the candidates and adds them all up. We want to find out how many received the maximum amount of donations from individuals, from political committees, party committees, and so on and so forth. So the mapper class creates a double writable array containing the value of each category for each candidate record. It finds the category with the maximum value, and then it writes a key value pair of maximum donation category for each candidate in text form, and a counter in interwritable form to context. The way that we find the thread-safe method of finding the maximum category cannot involve hash maps because the mapper class has to be thread-safe. So instead, you created an array of values, sort that array so that the max value is on the end, and then test each variable in the array to know which category is equal to the maximum value. So after that, the reducer class sums these records of category and counter to find the number of candidates that have each donation category as their maximum. Our third and final class finds the total amount of money that was contributed to candidates by private citizens for each state. The mapper class writes key value pairs of states from the candidate record and the total amount of donations that they received from individual contributors to context. Then the reducer class adds the total donations from each state and outputs a key value pair containing the state name and the total amount that people in that state donated to the election campaigns to the context. And that's the output. So as you can see from this chart, the data shows that 20% of candidates funded almost their entire campaign, while 80% funded either none or very little of their own campaign in 2015 to 2016. We divided percentages into increments of 10% because it was a better way of showing the data, because there were very few candidates who funded anywhere between 10 to 90%. In fact, in the entirety of 2015 to 2016, there were only 2 candidates who funded between 20 and 40%, and 0 who funded the rest. So the output for the next class is shown in this graph of maximum campaign donation categories. The majority of candidates were funded by individual donations, shown in yellow, followed by party committee contributions. Comparatively less were funded by loans, political committees, or themselves. And this was also found using a MapReduce class in which we found the maximum value of each category for each candidate record, and then wrote that to the context. So finally, for the state contributions graph, this was found by creating a key value pair of every candidate state and how much they received in individual contributions, which was added up in the reduce phase. For this graph, I didn't count candidates from US territories to keep output simple. Florida had, as you can see, the most campaign contributions out of any state. And also New Jersey is rather on the lower end of campaign contribution. This is because this graph doesn't account for populations in size or how many people were running that year. It just counts the total amount of contributions that were given in that state. So now Christian is going to tell you a little bit about how we evaluated these programs for load balancing and fault tolerance.